our project, we would like to make computers to understand the court verdicts. The problem is that the law is vast and complex. This is not an easy task for even experienced lawyer. In Poland, because we focus on the Polish law and Polish court verdicts, usually each year there are thousands of pages of legal regulation passed, go through Parliament, and on the other hand, the search engine for the court verdicts are not very well created. They based on keywords. In fact, for all Polish law, there was no AI search engine that allows you to search, to go through this legal information. So basically, most of those legal information systems in Poland are not so smart. So keywords and other stuff. What is the problem with the law? Basically, we have inflation of law in Poland. It's a lot of law, and if you go on the interconnectivity of the law passed in the first 25 years after we get out of the communism, it's quite vastly connected, so it's not good. So basically, first to start this project, we need to get the data. So we focus on the data sets from administrative courts, from the civic courts, and from the Supreme Court. And we try to get it, because if you would like to understand something, you need to read it. You need to read the book to understand physics or something. But there was a problem with this. They were keen to share the 1 or 2 court verdicts for the humans, but they were not keen to share it with the computers. So there was the first obstacle to develop the system. Well, we find a way. We just allow our scrappers to simulate the human, so it could get the data. So when we got the data, if you go through this is example of the court verdict, quite important one about the. It was the case with the Internal Revenue Office in Poland. You can see that there are logical parts to this court. Here is this is the essence usually, and there is an argumentation that it's used. But for example, if you would like to take a logical part, you need to take account this bullet point and stuff like that. But sometimes those bullet points are there is hierarchy to this one, and paragraphs tend to be long, especially for the civic courts. And usually, you need to extract the thoughts from it to get it. So the system that we build up, you can ask the question in the natural language. This was the question about what is the violating the law by misinterpretation or misuse of the law. What is the difference between those two problems? And this is a problem in the case. And for example, we could extract from the text that from the court verdict. This is from Supreme Administrative Court of Poland. The part of the verdict which answers the question with the setting in the law. And if you click on this one, you can get this part and what is the context of it. Okay, so how we did it? Basically, the first problem after getting the data was that it's more than 50 gigabytes of the plain text. So this is vast, and this is only publicly available verdicts. For example, the civic courts give you only a fraction of the verdicts that they have. And the problem with big data, it's not only the problem how big is your data. It's also a problem how intense computation you would like to make on this data. And we need to process the language. We need to build the language model that describes the legal language well, and to make an operation on this one. So basically, there is a branch of artificial intelligence called natural language processing, and we would like to that makes a computer to get the meaning of the text that it's working. Basically, it started from getting the meaning of the words. So if we go to the system, if we get the text, this is a part of a treaty in the European Union, and if you go to the word union, and you can immediately see that the surrounding of this word is totally different than of the word of economic. So basically, you extract the meaning of the word from the text based on its surrounding. Okay, this works great for English. There is a problem with Polish because there is a changes in the endings, prefixes, so it's a bit tricky, but we get to this later. Basically, if you describe the words as a vectors, for example, there's quite a famous equation that you get the vector for a king, then subtract the vector for a man and add the woman, you get the queen. But there is one thing. Those vectors are not two-dimensional vectors. This is only, you just extrapolate those vectors, you put them on the hyperplane, because those vectors, to really represent the meaning of the words, have to be big. Which big, I mean, it's about at least 100 of number. It's from the 100-dimensional space, but you get from this word-to-vec approach, the good results you get about 300 dimensions. It would be good enough. But there is an other thing, context. The context of the words change the meaning of the word. And for example, you can have the word bank, but if you have a Bank of England, you understand that it's bank like that. But if you get the river bank, you get this. So if you use this word-to-vec approach, the bank will have the vector which is taken from those two meanings. But if you got the context embedding, so the change of the vector describing the word rely on context, those two vectors will be different. But the problem is that those vectors are even bigger. It's thousands of dimensions. So basically, if we would like, now we can, from the vectors that constitute of a paragraph, we can create a vector that represents the meaning of a paragraph or logical part of the verdict. And those vectors could have a different length, but the direction of a vector describes the meaning of the paragraph. So we can put the meaning of those logical parts in verdict would be a sphere. So in the 2D we have it would be a circle. In 3D it's a sphere. Here is a sphere of 4D in 3D, and let's now imagine a sphere in 3,000 dimensions. How it would look like. But basically it's what we need to do. To solve to search for the vectors in the very dimensional space, the closest vectors. And our experimental setup to test our approach was questions for the exam for the tax advisor. So we took the corporate tax. We took the court verdicts for the corporate tax. We chop it into the logical parts. And then we produce vectors using our model for the language. And there is one tricky thing. If you have a vector with the question, you need to make some sort of transformation to the space of the logical part of the verdict. And then you can compare those two vectors and search the nearest points in the multi-dimensional space, which is also a very interesting engineering task. But about this, it's for the separate talk. What type of embeddings we took? We took the fast text, which was produced by Facebook. We took byte per embedding. We took character embedding. We took the FLAIR backward embedding. By the way, FLAIR was developed by Zalando Research. They use it to extract the data from the comments from the customers. So natural language processing, it's the thing that many people use that. And we use our own embedding that the paper would be published soon about that. And there are two examples of the questions. One was about can I subtract the cost of advertisement from the cost of running from the revenue of the company, and the other one was about selling the debts from one kind of type of contracts. And there are two K verdicts that basically solves your case. So we took those embeddings, and here we got, the character embedding in this case was good, was quite good. The byte per embedding was quite okay. The FLAIR solved one case, and we solved both cases, but here it's the first place, second place, first place, second place. Okay, but what was the problem? The answer here, why it was working better, was the character embeddings, which was good in both cases, search for the text that is similar. Similar in meaning of the words on the characters. but not in the meaning, because here in this case, the solution came with the information of what part of law to use. Here, the flare backwards also give you the part of word to use, but this paragraph is much better in terms of legal research. Here, we got the character embedding was okay, byte per embedding is also okay, but here this was from the good court verdict, but was not a good paragraph. The good paragraphs is here. So it depends on. So this is a tricky thing to search for search by the meaning what was good. We also make a test to rephrase this question, and in both cases our embedding was the one that got it right. The byte per embedding, the stability of the embedding is also crucial in this case. So basically, we started the system that we created that started as a university project is now delivered to the few legal companies, and we had the paying customers. But what the key points? The good language model is crucial for extracting the information from the text, and you need a very big corpus to do that, to train your model. Also, the Polish language is not an obstacle to do the NLP. And the system could be extended to other types of legal documents. Also, what we based on having this court verdict chopped to the legal to the logical parts, then we can compare the court verdicts, for example, related to the corporate tax, and see how the thoughts of the judge went in this case. Is it similar in terms of argumentation, or there are difference, and where the difference came from? And we probably the other phase that of the project that we would like to deliver soon is the predictive analytics that, based on the state, what was the state of the case, we presume the outcome and what would be the ways of thinking. And we have already this data, so we build up a base for the very intense AI research projects on the law. So thank you very much for your attention. I will be happy to answer your questions.